Hi, I'm Professor Catherine Hall, and I'm at UCL and in the Centre for Vascular Dementia Research. So we know that the brain is hugely densely vascularized, and neurons are incredibly energetically expensive. Oft said fact that the brain is only 2% of our body's mass, but it uses 20% of its energy at rest. And to get that energy, it's got this incredibly specialized vascular network. I mean, just by looking at the density of blood vessels in the brain, it's really obvious that they're really important. But we know increasingly that changes in blood vessel function and changes in blood flow to the brain precede problems in conditions such as vascular dementia and Alzheimer's disease. My research focuses on how the brain balances the energy that it uses with the energy it's supplied with in the blood. And so we're really interested in whether this balance between energy supply and demand is consistent across the brain, and what happens to the brain when the balance isn't quite good enough. So if there's not quite enough energy supplied to active brain cells, what happens to them? We think this might be particularly important in the emergence of dementia. So what ideally will happen when we understand a bit more about how this process works, so how the brain is able to balance supply and demand and by what mechanisms this goes wrong, we'll hopefully be able to prevent those changes that happen at the onset of disease and stop diseases from emerging, and also cut them off when we get early biomarkers of vascular change in the brain, so that we can stop neurons becoming damaged, that's hard to heal. It's much easier, hopefully, to get in there and preserve the blood vessels function and stop any problems emerging in the first place.